my talk is about staying in the driver's seat while you have an LLM or guiding LLMs while you're still in the driver's seat. As a little bit of an intro for what Adept AI is all about, we can go ahead and go to the next slide. Let me see if I can fix this video issue really quickly. Okay, can we see if we reload, if that works now? Cool, could we try playing this video? So what Adept AI is building is a natural language software collaborator. If we could try full screening this video, maybe. So what we can see here is that someone has entered in a natural language request to our model, and our model is now controlling the mouse and keyboard to sort of execute this task on Airbnb. The person here was trying to find like a weekend getaway in San Luis Obispo, California. We're training our model to use a variety of software tools. So here we're also doing something on Salesforce. And really the goal is for everyone to be able to have Adept carry out software tasks for them by describing things the same way you might describe them to an assistant. So we want you to feel like you have this universal software tool expert as your personal assistant or collaborator. And it's as if you were looking over their shoulder as Adept perform these tasks for you. And we can go ahead and go on to the next slide. So in terms of like how we're achieving this, it's not anything revolutionary. And we can sort of step through this a little bit. We start by training this foundation model. So something that has this general understanding of language or increasingly more inputs than that, and then fine-tuning the model to learn specifically how to do software tool actions. And ultimately, this means that our project is powered by large language models, and so it faces a lot of the same challenges that other products are facing, such as not knowing when to abstain, our model being a little bit overconfident, or having hallucinations in terms of inventing actions that maybe weren't appropriate given the context of the software tool, and all of the other problems that people have brought up today. The difference is maybe, though, that the stakes are a little higher because the model is taking actions for you. So we can go ahead and go to the next slide. So imagine a scenario where you were on Amazon doing a little bit of shopping. Maybe you wanted to buy a couple of books, and imagine you were on this page and you requested that Adept, add to cart. Now you'll have to take my word for this, but this seems like a pretty straightforward thing for our model to get right. There's this clear button that says add to cart. We can probably see how our model would map this request to that particular action really well. But if we maybe were to go to the next slide and imagine that you used our model to navigate to this other book and you sort of gave it the same request, add to cart, maybe before realizing that add to cart is not a part of this page. And now this is problematic, right? Because our model in an ideal world would sort of maybe ask you for a clarifying question because add to cart doesn't seem to be relevant to this page. But at the same time, as we all know, machine learning models can get things wrong. And there are now a number of wrong actions that it could take here. But one in particular is especially painful because where there used to be an add to cart button, there is now a buy with one click button. And semantically, those are even sort of similar, right? You could imagine that add to cart and buy now with one click maybe have similar sentence embeddings or however you want to think about it. The difference, though, is that in addition to buy now with one click not being the intended action of this request, it's a much more serious action. It has much more serious consequences. It's purchasing the book, and that is not what the user intended. And so how do we try and prevent these failures from being so painful to our users? Again, in this world where large language models have this huge failure space due to the nature of its incredibly versatile output space. We can go ahead and go to the next slide. So again, we're not doing anything revolutionary here, but the issue lies with the fact that we're sort of sending our user requests and without any sort of safety checks, just taking the actions from the LLMs as being given. So one of the things that we're sort of exploring, or we think is a good idea, if we could go to the next slide, is sort of surrounding our large language model with this guiding system. So this is like a number of checks that we can perform. such as checking action reversibility or maybe a content filter, to add a little bit more color to the output of our large language model. And the key insight, I think, is that these are not necessarily large language model or ML based checks that we can do. We could do simple word filters to start with. And by doing simple things that are not dependent on our large language model, we gain the ability to iterate really quickly because we don't have to incorporate that into our model to begin with. It gives us the ability to iterate on what the product might feel like if we had these sort of checks in place, and to make sure that we're moving in the right direction before we spend a lot of time up leveling the ability of our model. And so, by doing these things, we can maybe say that if the model is trying to do an action that we deem sort of irreversible, maybe we should also ask the user for confirmation before we do that. And ultimately, the goal is to use all of this to feed into our large language model and ultimately improve its capabilities. So, yeah, now's a good time to go to the next slide. Adept cares very deeply about our data engine. Hopefully, data engines are also not a novel concept, but the idea is that we have some model that we can deploy into our product, and we use that to gain user feedback. And we use that user feedback to then inform our data collection strategy, such that we're always collecting the data that is most impactful in terms of improving our model and improving the experience that our users are having when using our product that is driven by this model. Some things that we care about in particular, if we go to the next option. So we really value fast cycles at Adept. At Adept, we strive for 24-hour cycles for internal builds. So what this means is that every day we're building a new model, deploying it to the product that we use internally, and gaining user feedback on that model that day, and potentially updating our data collection strategy that day. And these short cycles ensure that we're getting fresh user feedback. Imagine interacting with a model that was maybe 2 weeks old. The user feedback is old. And so what that means is that any insights that you're gaining might not be relevant, because maybe a model that you trained today would not have those problems anymore. It also enforces a high standard of internal tooling. We care about our workflow reliability and our visibility and instrumentation that we need for fast insights. That way we're able to inform our data collection strategy every day. And it requires this really tight integration between engineering and data collection. We're always chasing that best data point that we could get to improve our model in the most impactful way. And so if we go to the next slide, there's sort of like three things that we've learned early on when building a product that's powered by LLMs, that's taking actions for you. They can fail in many ways, and you really want to focus on those which are most painful to your users. Again, these actions that are maybe irreversible or have high consequences if you get them wrong. I don't think we should shy away from non-ML checks on LLM outputs. We don't need to throw out all of the types of technologies and strategies that we've used in the past for controlling these automated decision-making systems that we've been building. And keeping a tight integration between data collection and product and engineering efforts, I think really makes the data collection efforts that you have more optimal and more efficient. And so we really value that as well. So those are sort of like the takeaways. I thank you for listening. And if Adept, here at Adept, we think that we're working on really difficult problems. And so if these sorts of problems excite you in any way, feel free to give our careers page a look. We'd love to chat.
Awesome. Thank you so much. And a couple people said that I didn't see the notebook. I can't see the notebook. Was that on one of the slides?
I think that might have been the previous talk.
Oh, maybe it was. Okay. And then someone asked, how would you integrate with something like Mac Automator?
Mac Automator. Well, I don't know if I could speak to that explicitly. I'm not super familiar with that tech, but if I could, imagine what it might look like. So we spend a lot of time sort of trying to collect data that really maps a user request into these sort of like action space that you would need to do to execute that. So in the browser, it's like, given a user request, what sorts of like things do we click or key down in order to achieve that task? So I imagine in Mac Automator, there might be like a similar thing that we would try and map to if we wanted to leverage that technology. Right now, we're doing everything in the browser. But we think that the idea in general extends to things that like sort of take control and execute tasks for you.
Awesome. Well, thank you so much, Jacob. This was wonderful, and it was a great note to end track 2 on. So thank you so much again.
Thanks for having me.